Today, we are going to dive into one of the most exciting aspects of 5G use case and applications, from smart cities to autonomous vehicles, IoT to AI-driven innovations. We will explore how 5G is transforming various industries and shaping the future of our connectivity. It's an honor to introduce today's distinguished speaker, Abhijit Lele. Abhijit completed his doctorate from Indian Institute of Science and is a distinguished senior researcher and innovator. With over 25 years of experience, he has worked across a diverse range of technologies, including security, wireless networks, cloud computing, and AI ML. His industry experience spans Motorola Research Labs, Samsung Research, and Robert Bosch Research Labs. He's a true frugal innovator. Abhijit focus on India-centric use cases, driving sustainability and efficiency across multiple industry sectors. His innovations span energy management, agri-tech, and fintech domains, bringing cutting-edge solutions to a real-world challenges. Today, he will share his expertise on how 5G is enabling transformative application across industries. Without any further delay, let's welcome Dr. Abhijit Lele as he takes us through today's session on 5G use case and applications. Let's extend our warm virtual welcome.
Thank you, Ruth, for the introduction, and good afternoon, all. My name is Abhijit Lele, and I'll take you through in the next 1.5 hours, or whatever time permits, on various use cases where 5G plays an important role. And when I say 5G, it is basically connectivity, exploring some of the properties of 5G like low latency or high bandwidth, so on and so forth. The idea is not to do a deep dive into all the use cases, but more or less the idea is that to share the concept, probably discuss a bit about what are the challenges and problem statements. And very specifically, I would take one or two use cases where there is a special focus from Government of India. Either they are important use cases of national importance, or there is certain localization that is happening, or bringing in sustainability, trust, and efficiency into the system. One or two such use cases is that I will deep dive into. And let's keep it interactive as we go along. Please feel free to ask your questions either in the chat box, or stop me if there are any questions. At a very, very high level, if you look at any industry report, it is said that the 5G networks will drive innovations in various sectors: agriculture, construction, education, intelligent retail, smart manufacturing. And these are some of the numbers that have been put forth by various industry leaders on how these innovations will shape up the various segments of the industry over the next few years. I would put it that way. Now it is up to us on how we can explore some of these use cases or some of these domains and bring in innovation, bring in technology advancement in various sectors of this. I'll be touching upon a few of these sectors, especially agriculture, smart manufacturing, smart cities, as we go along. Also, the automotive domain is what I would touch upon. And as I said, the focus would be on things that the Government of India or the various research communities feel that are important. If I were to look at the characteristics of 5G that drive some of these use cases, and I'm sure in some of the previous sessions in the last 2 or 3 days, you would have looked at some of these characteristics. So I'm not going to get into a deep dive of this, but high availability, low latencies, highly reliable, GPPS data rates, also providing connectivity at 500 kilometers per hour in ideal situations, very high battery life in terms of, before it depletes in the 5G network are some of the characteristics, right? Now, what does this mean? If we were to translate this to use cases, GPPS high peak data rates would translate to that I can take, let us say, data from a sensor which has very high data rates. For example, a LiDAR, a camera, a video camera. These are very high data rate sensing. And I would still be able to push my data into the cloud for analysis or into the fog layer for some data analysis. If I look at low latencies, ultra low latencies, 1 millisecond data, right? But at a lower bandwidth. For example, if we take the automotive use case, wherein we have a telematics device on an electric vehicle pumping out battery management system data, which is typically acquired at 10 milliseconds, right? Now I can build intelligence into my system using this ultra low latency characteristics of the data and try to see if I can predict certain thermal runaways in EVs, right? So what we are trying to do is map these characteristics of 5G networks onto use cases in various verticals. Now, if we look at battery life, for example, in agriculture applications, once you deploy a device or a sensing device, you might not want to replace the battery at very high frequencies, right? For a year or two, you might want the battery to run, yet you might want to acquire the data as you go along. So these are the characteristics that get exploited across various verticals, and we will explore some of these as we go along. So broadly speaking, if you look at the use cases, they can be at a very, very high level partitioned into smart agriculture, smart manufacturing, smart telehealth, smart energy and utilities, smart cities, and smart education. I mean, this is not the full laundry list. You can have smart construction, so a lot of other things might have been missed out here. But at a very, very high level, these are the areas where the use cases can be kind of clustered together. And if you look at the right-hand side of this, these are the characteristics where the use cases get mapped to. High speed, low latency, connection density, reliability, and energy saving. Right? These are the properties of 5G network to which these various use cases get mapped to. For example, if you look at smart cities, uh, almost every characteristic of 5G network is exploited in the smart city use case, right? We will have cameras that are monitoring various infrastructure elements. We would have sensors placed for monitoring, so on and so forth. Right? So whereas some other domains like smart education typically will exploit high speed and reliability more, right? So each domain has its own nuances where different characteristics of 5G networks are being captured. We will touch upon some of these use cases as we go along. Now, before we get into the various use cases, there are three exemplary projects that are going on at Art Park. One is called as the drone corridor. This is for the sake of completeness that I would mention all these three projects before we do a deep dive into the use cases. Because somewhere or the other, what is being investigated at Art Park is also very important use cases that stand are the priority for the industry today. The first of the projects is the drone corridor. The drone corridor is all about defining pathways in the sky for the drones, right? Using 5G network connectivity. How do we define, just like in aviation, we have pathways where the planes traverse. There is a fixed technology that has been matured over the years. Can a similar thing be done for the drones. And this is the outcome that this program is targeting for, that can we define a drone corridor and can we use a 5G network based localization and ground truth generation where this drone corridor gets defined. So this is the first program out of ArtPark, where the application of the 5G in defining pathways in the sky is being explored. The localization properties of the 5G network would be exploited as a part of this program. The second project that is going on at ArtPark, and I will do a deep dive on the Industry 4.0 as we go along, is the factory digital twin, right? So uh, today, everyone is looking at efficiency. Everyone is looking at bringing in efficiency, reducing the cost of manufacturing, reducing the cost of materials, reducing the wastage in real time on an industry floor, on the shop floor, basically. How can this be achieved, right? And also how the cost of running a shop floor be optimized. Now, this is where a lot of things come together. Robotics can be used. We can have ATVs that can be used on the shop floors for milk runs. We can have just-in-time delivery of raw materials. A lot of techniques can be used to optimize the entire production flow. And one of the ways to achieve this is to create a digital twin of the factory floor. The digital twin is nothing but a real-time live model of the factory floor, which kind of mimics what is happening on the factory floor in the digital world, right? And based on what is happening on the shop floor, if I can create a replica of it in my virtual domain or in my digital domain, various optimization algorithms can be built on top of it. And then decisions made in the digital domain can be communicated back either to control processes, to control various activities, or to provide recommendations to the users so as the entire system gets optimized, right? And the outcome of this, what we are looking at, is to build a simple digital twin to start with. And can we recreate the shop floor via Gaussian splatting techniques and build a digital replica of what is happening on the shop floor, so that at least in terms of the milk runs of the vehicles, etc., object detections, it is very easy to mimic that in the digital world and appropriate decisions being taken. So this is the other program that is going on at ArtPath. And the third is about vehicle safety that is going on here. Uh, Today, four-wheelers, for example, there are a lot of safety features built into the four-wheelers or connected four-wheelers. For example, airbags, for example, ABS, anti-braking systems, anti-brake lock systems, sorry. Uh, Also, a lot of sensors like parking sensors are there. We have assist for reverse assist, so on and so forth. But a very little safety features are available for two-wheelers. I mean, it is an upcoming domain, and that is where we are targeting that if we have a two-wheeler that is enabled with, let us say, a telematics device, giving the vehicle parameter data. We also have infrastructure data, for example, from cameras placed at traffic signals or on the road, so on and so forth. By a fusion of some of these data sets from the vehicle and from the infrastructure, can we enable certain vehicle safety use cases? Especially, we are looking at pedestrians and two-wheelers. Can appropriate alerts be provided? I will do a deep dive on this later in the presentation, but broadly speaking, the use cases around vehicle safety for two-wheelers and pedestrians using 5G networks as an enabler. So these are three exemplary projects that are ongoing at ArtPark with respect to 5G and the various domains of drone corridor, Industry 4.0, and vehicle safety. Okay. Now let us come to come to the various use cases that I was talking about. I'll start with smart agriculture, and then we will move across the various themes as we talked about. Okay. Uh, Now, if we look at smart agriculture and its applications as we go along, in summary, real-time monitoring of agriculture is very well known in the sense it has been in use, especially soil moisture. In fact, the NPK values of the soil have been in use for precision agriculture. Depending upon the moisture content, the humidity of the soil, you can turn uh, on and off the drip irrigation in an agriculture domain. So this is the real-time monitoring part of the soil, uh, linked to precision farming, wherein you control the various minerals that can be given to the crops as a part of precision agriculture. Now, over the last 3 or 4 years, AI-powered robots, both from, so if you look at the life cycle of agriculture, there is a preparation phase where you need to prepare the land and the soil for various, before you sow the crops. Like there is tilling, then there is something called as mulching. There are a bunch of processes that happen. Lack of manpower is driving farmers to adapt certain robotic technologies, which can be add-on to tractors, or they can be autonomous vehicles. They can be all-terrain vehicles. In fact, Art Park is also building an agri all-terrain vehicle that will be soon demonstrated and deployed. Now, this is where the all-terrain vehicle, all the tractors and these equipments can be equipped with sensors like lidars, cameras, so on and so forth. And based on this, either remote driving is the use case that can be driven out of this, or even autonomous vehicles. Now, autonomous vehicles in an agri domain have a completely different method by which algorithms have to be developed, because it is not about obstacle detection. Everything is an obstacle. It's basically about the task at hand and how do we execute the task. So it's an entirely new realm that has to be dealt with in AI-powered robots or AI-powered vehicles. The augmented and virtual reality part comes in conjunction with this. So imagine a service, and this is also a very interesting thing that a bunch of startups are trying out, of virtual driving, right? We are sitting in a call center. You basically have a vehicle which is equipped with a 360-degree camera and lidar. You wear an augmented reality device, a headset around it, and then you feel as if though you are in the field. And then you are virtually driving the vehicle in the field as if though you were physically present there. And that is where some intelligent use of virtual and augmented reality is coming into play in the agri domain. And of course, this is, it can be a service. Basically, you can rent a service for, say, tilling your agri land. Someone in the call center then drives the vehicle to your farm, sitting virtually in a call center like environment, tills the field for you and then comes back. So these kind of use cases will soon become a reality. There is a company called EMC3 or EMC2, which is from the ex-head of Airtel who is driving this effort. They have launched such a service in Madhya Pradesh and Maharashtra currently. And yeah, they have big plans to make this available on a pan-India basis as we go along. The other domain that is picking up a lot is unmanned aerial vehicles, UAVs or drones, in order to survey the crop, both from the perspective of health monitoring of the crops and also for the green cover of the crops. So this is also a technology where either drones or UAVs are equipped with sensors, especially cameras in the visual range, also in the near infrared range, uh, in order to sense whether there are certain diseases on the crops, especially on larger fields, analyze the data, and then also carry loads of, say, insecticides or pesticides that can be sprayed on these farms in a fairly precise way, I would say, right? Rather than doing a complete farm being sprayed with insecticides, it can be localized to areas which are infected. This not only saves the cost for the farmer, of course, there's a cost to doing a sortie of a drone or a UAV, but then it saves a lot of cost of carpet spraying of insecticides and pesticides which are harmful to the crops. So these are the categories of use cases that emerge in the agri segment. However, let me touch upon a few very interesting use cases that are being investigated today, and there is especially a budget allocated for such use cases. Sorry, agencies like BIRAC, etc., are encouraging people uh, to participate and to build technologies for such use cases. So we all know that today, I mean, in India, agriculture is one of the major businesses. The other challenge we have is fragmentation of land. That is, no farmer, no single farmer, apart from, let us say, contract farming, is an owner of a big chunk of land, right? The average ownership pattern in India is about 3.3 acres. Uh, Now it doesn't make sense to, invest in lot of technologies uh, which bring in efficiency to increase the yield or to optimize the entire production process. This is where the government of India started an initiative which was called as a soil card, in which every farmer was encouraged to take a sample of their soil. There were certain empaneled laboratories, submit the soil sample. In return, he would get a soil card. Based on the soil card, certain recommendations would be provided to what crop he should plant, etc., so as to maximize the potential of the yield. This also gave government of India, which I will touch upon later, a way to kind of, understand the overall soil productivity countrywide. But this entire ecosystem now is not efficiently managed, in the sense, uh, there is a lack of trust in the entire system. You go out to the market, you can, of course, get a soil card at a certain price point, etc. A lot of broken bits and pieces are there. So what the government is encouraging is, can I have a low cost sensor in the hands of the farmer or an FPO? FPO is a farmer producer organization. uh, this sensor can be about 5,000 rupees, 10,000 rupees kind of a sensor. It can be chemical based, it can be NIR sensors or something where I can measure the major macronutrients, that is NPK values, nitrogen, potassium, phosphorus, and certain, there are 8 micronutrients like copper, boron, manganese, iron, cobalt, so not cobalt, copper, iron, manganese, so on and so forth, right? There are 8 of them total, right? Can I do this? So the idea is to build a low cost device, get the data to the cloud, or get the data somewhere where certain computations or machine learning or AI algorithms can be used in order to determine the NPK values and the micronutrients of the soil. And based on this, provide certain recommendations to the farmers towards increase in yield, type of crops to be planted, so as the overall productivity and sustainability can be brought onto the ecosystem. Now, this is where, guaranteed communication or connectivity to the backend will play a very important role. Okay. So the second part of it is you log and analyze this data to look at whether the soil or the crop is really what it is claimed to be, right? So in India, we have something called organic farming, right? There is a certification that is issued by the government of India when the farm is or the land is certified to be organic. This is a 3-year process today, right? So the farmer has to submit a soil sample, certain tests are carried out, and then after a period of 6 months, again some tests are carried out. Then over the period of 3 years, after about I don't know 9 or 10 tests, that is when the farmland is certified to be organic. And then whatever gets produced there, assuming that during the crop cycle he does not utilize any chemical based insecticides, pesticides, or fertilizers, the crop or the produce is called as an organic produce. There is absolutely zero traceability here, right? Apart from the certification that the government of India has issued, but the markup price on this varies anything between 100 to 800% depending upon the type of crop. So, for example, saffron, if it is organic, is marked up by almost 300 to 400%, right? But with very, very minimal traceability. Apart from the 3-year period of certifying that the land was indeed organic. And this is where near real-time sensing, let me not say real-time sensing, near real-time sensing can help establish traceability. And the idea of this is the benefit of organic farming is at the end of the day not going to the farmer. The benefit is going to the intermediaries, and then they manage the entire ecosystem just to say that the farming is truly organic. Now, if an end-to-end traceability via real-time sensing can be established, I think we would bring in credibility in this entire organic certification chain, right? Then comes in, let us assume that this organic certification is somehow managed, fixed, or technology interventions possible. Of course, there are a lot of farm to plate, farm to fork kind of methods or platforms today that are available, but these are very hyper local, and naturally so. So there is a big kind of avenue that is still available because the entire fresh fruit and vegetable market, which is called as FFP, is fairly an hyperlocal ecosystem, right? So in this hyperlocal ecosystem, a lot of scope is still there to ensure the demand supply management, right? So whoever has a produce, can that be brought onto the plate in, let us say, 3 or 4 days time, because the lifespan of the product is just about 3 or 4 days. And this is where ONDC, which is the most popular platform today for, and it is a digital public good infrastructure, open network digital commerce, is building a complete agri ecosystem where demand supply management, connected demand supply management is, they are trying to bring it up. Now, one of the layers that ONDC is trying to build here is the layer of differentiated pricing, right? So if I have to buy tomatoes for 1 kg, someone might give it at 20 rupees, but if they are pesticide free, I might want to demand 40 kgs. Now, if I combine this ecosystem of sensing and traceability and integrate that with my ONDC ecosystem, which is a demand supply, I would be able to provide a differentiated pricing, right? This is exactly the layer that ONDC is trying to build in a connected ecosystem when it comes to demand supply management, right? Now, the last angle for this, all of this is fine, but then farmers need money to manage their entire crop cycle, right? So fintech is very important. And today there are several schemes. For example, government is giving certain subsidies to farmers, but there is very limited traceability. If you look at farmer loans, typically they go NPA. I mean, 70-80% of the loans that are extended to farmers are NPA. I'm not saying everything is good or bad, but some are deliberate, but some are genuine. Now, how do you trace the genuine cases? So if a sensing technology is integrated with a fintech platform, That fintech platform, because of the traceability, we can bring in the farmers into the regular credit cycle, right? So what is happening today is the farmers, if you look at the statistics from Government of India, only about 30% of the farmers today have a PAN card. They do have an Aadhaar card, but they don't have a PAN card. Okay, and because they don't have a PAN card, they don't have a CIBIL score. Because they don't have a CIBIL score, they do not have access to fundamental instruments, and they have to rely on various government schemes with multiple set of documentations in order to avail a scheme. Now, if certain traceability can be brought in, I think that's a big value add for this, right? So these are the smart agriculture use cases. So this is during the crop cycle of a farm, of a crop. The other use case that emerges from here is post-harvest, right? So not many farmers today are aware of the post-harvest use cases. That is, what happens to their agri waste. That is, you can do briquetting. There are a lot of players today who are trying to do briquetting, who are short of supply of agri waste, who can keep their briquetting plants running. And the government of India has also mandated that 7% of the thermal fuel today would come from agri waste briquettes. This is a law that has been passed by the government of India. I'm sure not many are aware of this law. And each briquette would have certain calorific values, right? It is, I think, 3.4 or 3.7 kilojoules per kg of a briquette, if I'm not wrong, something like that, right? So if a traceability is established, the end calorific value of a briquette can be determined, getting a good price for the post-harvest briquetting as well. And then also the carbon credits. If you are on organic farming, or if you are using accountable way of chemical farming, soil is the most carbon storage tank, I would say, on planet Earth. And if a traceability is established, you get access to carbon credits as well, right? So these are side streams that can be enabled via traceability in the agri domain. Now, this is where, the government is looking at building an end-to-end traceability platform of sensing that drives the soil quality, that provides recommendations for the type of crops, overall increasing the yield, that provides farm to fork via the ONDC platform, and I will come to how the logistics of it is managed later on. This comes to post-harvest, where, a lot of things can be managed and additional revenues can be brought through. So these are some of the use cases during the crop cycle and on the post-harvest phase. There is a very interesting thing on land degradation in India, where there's a lot of interest again at a government or at an pan-India level, right? So, India's cultivable land today is declining every year. And there are several reasons for this. One is basically, random use of fertilizers is one reason for that. But apart from that, there are certain natural regions where there is rocky waste, so on and so forth. And then there is something called as wind erosion, etc., etc. So there are a lot of contributing factors to this. But one of the very interesting contributing factor is something called as lantana camera. So this is kind of, an unwanted weed which is eating into the Indian forest. It came in somewhere from Europe or South America. And once this weed gets into the ecosystem, it kind of starts spoiling your soil pattern, or it makes the soil non-cultivable. So there is a huge need to use technology interventions in order to monitor the spread of this lantana camera. So if you looked at lantana camera, it has a very colorful flower if you look at, but over the period of 5 to 6 years, it makes the entire soil uncultivable, right? So if you look at this data, this is the data from Government of India. Almost about 154,000 square kilometers of forest area is where this weed has been found. Forest or cultivable area, let me put it that way. Now, what the government is saying, especially, uh, is can we do satellite imagery? Can we do UAV fly past along with sensors? Can we do, say, drone fly past, combine all of this data, and then use this data to first identify where this kind of weed, I mean, this is the largest weed, that's why I've given this example. But there are other minor categories of weeds that are also eating into our forestry, right? So if technology interventions can be used in order to identify this, and then certain measures be taken uh, in order to reduce the spread of this specific weed, right? The overall impact on the cultivable land will decrease. Tamil Nadu is the forerunner in this. Recently, over the last 1 year, they have covered almost about 75,000 square kilometers of mapping of lantana camera using UAV flights. Okay, how successful and what mitigation strategies they would use needs to be seen. But at least they have started doing it. The other area is Uttaranchal or Uttarakhand, I would say, where again there have been technology interventions as a combination of satellite imagery and UAV flypasts in order to identify this weed. Now, there are several reasons for, the land degradations and the overall lower productivity. Let's keep aside, the people aspect of it, the political aspect of it, but what technical interventions are possible, right? So one of the things is we are not aggregate. There is no single protocol or there is no single information model. This is slightly beyond connectivity and 5G, while connectivity is still an enabler, where all the information can be aggregated into a single database, I would say. There is a database that Government of India has made. It is called farmers.gov.in, where still a lot of data is being aggregated, but it still remains in silos, either at a state level or at a district level, and that aggregation is still not happening. So a lot of players, be it government, be it NGOs, be it private players, still need to work together in order to bring all this data and digital databases together, where information modeling, knowledge engineering, connectivity will all form a key part in order to enable such an ecosystem. The other opportunity space is on carbon sequestration in the agri domain. In carbon sequestration is about when the leaves fall on the soil, they get degenerated into carbon. The soil stores the carbon. The soil is also a big absorber of the carbon, and then this leads to what is called as the NDC, Nationally Determined Carbon Contribution. Now, there is the government, or there is a huge program in place where there is a need to assess the NDC potential on a pan-India basis. Now, this is where the soil sensing, along with the drones and the UAV flypasts, are very helpful in order to determine the carbon sequestration part of the story. So the need of the hour is to build a platform, something similar to what is shown in the picture here. We have to simplify the process of data acquisition. We need digitizing protocols. We need to then make the knowledge engineering available at a hyperlocal level in a hierarchical way so that it aggregates at a national level. And we need to orchestrate the process between multiple players of NGOs, government bodies, government departments, ministries, so on and so forth. While the ask is huge, the rewards are equally huge, right? And it's time that we take up this initiative, uh, to not only enrich the farming, but also, bring in sustainability and effectiveness in the agriculture domain. And then, of course, there are a lot of business models that can evolve out of this, right? Differentiated pricing of food products is one. Contributions to NDCs, if it can be assessed, carbon credit hedging. There are companies today like Enking, Impulse, which do carbon credit hedging today. They're looking for inputs in a very trusted way where audit trails of carbon credits are available so that duplication of carbon credits is not there. So there are very valid business models around, smart agriculture, farm to fork, including carbon sequestration or even mapping of the forestry or mapping of the soil, so on and so forth. There is a need to build a platform uh, which will scale to a national level, not only here but also globally. I would say, beyond India. So this is what is the agri domain. I'll stop here if there are quick questions before I move to the next domain. Okay. If there are no questions, let me take on the next domain of smart energy uh, as use cases. In the smart energy domain, let's look at where we stand today and what is important for us. Uh, these are figures from 2016 or 17 from Ministry of Power report. 85,000 crore rupees worth of power is lost every year. Then 25% of the power produced is lost. 6 hours of average power cut. 240 million units of energy is consumed only in 4 metros, and there is a 92 billion unit of power deficit. I'm sure things would have improved over the years from over the last, I would say, 10 years or so, 8 or 10 years or so. But more or less, the philosophy that this paints is a very interesting philosophy, right? So we are, as a producer, we are power surplus. But as a consumer, we are power deficit, which basically means that we produce sufficient. I mean, take this with a pinch of salt, but numbers indicate like this. I think we are somewhere around 3.45 terawatt of power production, and 2.94 terawatt is our consumption pattern of this, right? Uh, sorry, 3.94 is our consumption pattern. So we are short of some zero point 0.9 terawatt of power. Now, why is this very interesting? Because most of our losses are distribution losses, right? So some are unavoidable, which are called as technically aggregated technical and commercial losses. Any transmission loss, I mean, because it is a resistance, is unavoidable. But then, our distribution networks, which comprises of, from the pole or from the transformer to our home, that is where all the losses occur, right? And that is where the inefficiency in the system is coming in. Secondly, then we have this issue of power factor, be it an industrial load or the home load, wherein the power factor kind of is very poor in India. No one cares to have the right power factor. So there are certain fines that the government of India has implemented if you don't maintain the power factor. The other important factor that influences the losses is the transformer, right? So typically we see these transformers near our homes or apartment buildings, anything between 250 kilowatts to lesser 33 kilowatts, so on and so forth. Uh, A transformer works best when it is loaded about 80 to 110%. But in many cases in Indian cities, you would see the transformer load right up to 180%, which brings in a lot of efficiency. If you go to something like BESCOM today, BESCOM officially on its website has said that they have to replace transformer worth 75 crores every year. Not a huge number considering that they have 5 lakh transformers. Price of each transformer is close to about 2.5 to 3 lakhs. But still, this loss of transformers or the transformers going bad because of heating, because of magnetic effects, etc., is still very, very large. And not to mention that it adds to the overall AT&C losses, aggregated technical and commercial losses, right? So this is where the Indian ecosystem in the energy stands. While we are surplus on the generation side, we are deficit overall on the consumption side, primarily because of aggregated technical and commercial losses in the system. Some of them are completely avoidable if proper monitoring of the infrastructure can be done. Also, the transmission side is much more efficient than the distribution side for whatever reasons they are. But this is where Government of India has taken several initiatives. So one of the initiatives is they have launched a program which is called as an RDSS program, Restructured Distribution Smart something. I'm forgetting the full form of it, right? Where the idea is that every home in India by 2028 will be equipped with a smart meter. So what does that mean? That no one will manually come to your home in order to take a meter reading. Okay. These meters would be equipped with a communication modem, I would say, or the communication interface or the module, wherein on a predefined date, at a command from the central unit or from the cloud, the meter reading would be taken, aggregated, the bill generated for it, and the bill sent across, right? So this is what a typical smart meter application would be. The way the architecture today is built is from the smart meter, it will go to an RF. The smart meters will form a mesh network. And then we will have a gateway which operates on one side with a mesh network, but the gateway then uploads the data to the cloud over a communication module, which typically would be a 4G. And now there is considerations of using 5G at the gateway. And then this data would get aggregated at a central location. Typically, the DESCOMs, like BESCOM in Bangalore or different cities, would have different DESCOMs. And it will not only provide automated billing, is just one outcome of this. Right? The real outcome of this is the amount of analytics that can be generated from this. Imagine if we have consumption data from every home and a similar infrastructure is put in for transformer monitoring. The correlation between that will actually tell us how much load is there on every transformer, what is the demand. We can really, really optimize the entire grid operations based on this data, right? So this is also called as demand supply management in this domain. So this is the largest rollout globally that is happening on automated meter reading, the AMR or AMI, automated metering infrastructure or automated meter reading infrastructure. So the use cases are for smart metering. So it can provide remote management for meters. It can provide information for decision support and utilities. It helps optimize demand and supply. And also, by 2028, there is a talk of having smart street lighting, right? So street lighting is a major consumption of power in India. Across the cities, it contributes to almost about 0.8% of the power, which is still a huge, huge number, I would say. And having smart metering depending upon, say, sensing technology like light conditions, weather, etc., can really help save the power. Today, smart lighting or street lighting is timing based. Whether there is light or no light, they switch on at a predefined time, say 6:30 or 7 in the evening, and they switch it off at a predefined time in the morning. So many times you will see that the street lights are on even if the sun is very bright, right? So this basically consumes a lot of energy and electricity. So this is where a lot of optimizations can be offered. So the total program cost, there would be 250 million electricity consumers or smart meters. Now this number has been revised to 410 million. And the government has announced a US 2.5 billion grant to support smart meter rollout. Right. So this is the business of rolling out a smart metering infrastructure. As I said, if you split down this business, one is about making the smart meter, the other is making the COM module, the other is making the gateway module, which typically would be 5G enabled. It can also have certain local computations out there where some intelligence at the edge can be built, so on and so forth. So a lot of use cases get emerged out of this. Those of you who are interested in the details and are thinking of, building use cases, technologies, products in this space, it has been awarded to 46 players as of 2023. Some of it is what I have listed here: Genius, IntelliSmart, Adani, GMR, so on and so forth, and the amount of smart meter units that have been awarded for their installations. Now, why I'm mentioning this is also many of them, while they have smart meter technologies, a lot of them are struggling to aggregate the data at the gateway and push it to the cloud. It's still at a reasonably nascent stage with a lot of scope of building a robust product at various stages in this ecosystem. That's the reason I put in this slide under the Smart Meter National Program. And who are the people who have been awarded and who are looking out actively for technology partners who can be enablers for various pieces of this deployment. Okay. Now, assume we roll this out, then there is a whole lot of backend that happens. All right. So this is the smart grid infrastructure. So from the transformer that we have, it goes to the substation. From the substation, it goes to the regional distribution center. From the regional distribution center, it goes to the regional dispatch center. From there to the national grid, so on and so forth. I'm not getting into the full details of a smart grid solution, but it is a layered architecture that India follows. So we have, if I'm not wrong, 5 grid zones in India: South India, East, West, North, and the Central India locations. And then we have various substations at the bottom layer. If you look at it, these are called as IEDs, intelligent electronic devices. These intelligent electronic devices monitor the power line, aggregate the data in what is called as the remote terminal unit. The remote terminal unit transmits this data to the local HMI and the substation gateway automation platforms. So if you visit a digital substation platform in your locality, you would see what is the overall load, how much is the efficiency, how many transformers are working at what loading factors, etc., etc. Right? Now, data from multiple of these substations get aggregated to a citywide or a local substation. And again, you would have, this is the level 3 network operations. And then so on and so forth, and the entire hierarchy is built. So the power flows from the top to bottom and the information flows from bottom to top, so that a centralized, localized information flow is available at different layers of the hierarchy at different levels of detail and control, right? Now, if data is flowing, obviously there is a need for connectivity. Today it is an air gap network, that is, there is no wireless network in the loop, but again, Power Grid Corporation of India, PGCIL, is very actively looking for technology interventions which can help them provide secure data connectivity between various data layers. Because this is the area where, if one layer is broken and you can inject false messages, false controls, the entire network breaks down. And there is a huge effort today that is ongoing to localize the manufacturing of the communication equipment. Most of these communication equipments are provided by the big 4 or 5, that is ABB, Siemens, Alstom, Hitachi, so on and so forth. But PGCIL is operating with a mandate that in the next 15 years, they want to see 15 to 20 years is the horizon, because it's not possible to replace it one shot, legacy networks, that we would have a homegrown solution for the data flow. And that is the opportunity space that PGCIL, Power Grid Corporation of India, and the operator of that, which is also called as Grid India, is looking towards. In IISc, we have a center which is called as Power Grid Center for Excellence in Cybersecurity. Some of the programs are being driven out of that center in order to build such a secure communication network for the power grid. Okay. And in the process of this, there is a framework. So today, most of this is based on, an IEC 61850 protocol. It comes with its own pluses and minuses. But then the question asked is, IEC 61850 was not, when it was defined somewhere around 1994-95, matured around early 2000s, came into play around 2004 or 5. So the original definition was not meant for data intensive networks. So the question being asked is, when we move to the next generation smart grid infrastructure, should we continue with IEC 61850, or an extension of that is mentioned here is IEC 62264? Or should we move to a new paradigm which is called as Open Process Automation Framework? Okay, Open Process Automation Framework is, I wouldn't say an alternate, is being talked about in the smart grid world now globally as probably the next generation protocol or the next generation framework for the information flows, right? In order to enable what are called as digital substations or digital smart grids. And this is another area which, again, agencies like PGCIL or Grid India are looking at. If there are players who can build indigenous devices, hardwares, protocols, validate it, build the test suits for it, certify it for security and cyber security, and see, where this stands. This is where I would stop when it comes to smart energy. So 2 or 3 opportunity spaces at scale, I would say. One is the smart metering infrastructure, and the other is in the smart grid domain, how do we define or decide or manufacture or build information flow infrastructure elements? Like, for example, a couple of keywords is data diodes, for example, or smart switches, because most of this operate at layer 3 for security reasons. Point-to-point layer 3 protocol, so on and so forth. So that's the opportunity space that is available. Of course, there are other commonly used opportunity spaces like energy saving for industry, where you monitor various equipments for energy consumption patterns and then try to optimize the energy consumption patterns. There is also a lot of talk about optimizing HVAC, because HVAC is the major consumption of energy in both industry and in smart buildings. Right. So I deliberately did not touch upon those use cases because they are fairly well known, well understood. But this is something new that is coming in the field, which I thought I should bring to the notice. So that's where I come from. I'll move to the next domain uh, of smart manufacturing. So we also have a pilot program, or as I said, a showcasing program at Art Park on the smart manufacturing process. It's a very, very large topic. So I'm going to give you a very, very high overview and talk about a few relevant themes, I would say, not even use cases, that might be relevant in the context of smart manufacturing. So if you look at the entire smart manufacturing ecosystem today, production monitoring, enterprise resource planning, supply chain, quality, robotics, industrial control, power control, asset performance management, computerized maintenance and management systems, distributed controls, etc., are broadly the domains that every industry 4.0 today, target about. At various levels of maturity, at various levels of detailing, every industry to a certain extent have some of this in place already. Right? Now, if we were to spill this out into what is the target of an industry 4.0, right? So typically they will target utilization, flexibility, mobility, productivity, quality, and safety and sustainability. Broadly speaking, you can categorize the outcome of any industry 4.0 would be related to, in some form or the other, to one of these 6 or 7 goals. Let me put it that way. Okay. And then if we look at how to achieve this, right? So factory automations, process automations, HMIs and product IT, logistics and warehousing, monitoring and maintenance are the different verticals or solutioning space, I would say. Of course, analytics, AI, ML are all a part of this. 5 broad categories that would come into it, right? So these are the 5 broad categories where industries look out for solutions in order to address one of these 7 things: flexibility, mobility, productivity, etc., etc. Right? So, and some of the high level use cases, what I have mapped, this is not a full laundry list. Okay. But some high level things which I have put in place here. And the logic for this is taken from 2 large, I would say, European Union programs, along with Government of India, that have been conducted or are being carried out in various industry segments. Okay. So what is of interest? I'll not go through every part of this, but what is of interest is, I think, the 5G versatile multi-sensor platform for digital twins. I think there's a huge initiative from Government of India and also the industry players. It's of a big interest to build a digital twin, not only of the factory floor, but also of individual processes and machines that comprise or that the factory floor is made up of, right? Especially the rotating machine. There is a large program uh, which is driven by Government of India for the digital twins, where they have asked for industries and industry and academic participation in order to build digital twins. One of the areas of big interest can we build real-time models for rotating machines? Can we build digital twins for rotating machines? Especially in the context of mission critical shop floors, and they are looking at 2 or 3 mission critical shop floors. One is in the shipyard domain, the other is in avionics. uh, Apart from this, of course, we have this Navratna companies, which is IOCL, some cement factories, especially on the IOCL or the petrochemical part, right? So again, there is a huge interest in order to build digital twins for all the machinery and equipments for IOCL, especially on the petroleum production part, and then use that for various factors, not only for optimizing costs, but mainly from a safety point of view also.